Okay, students. So now we are going to illustrate or try to understand the relationship between the magnitude of force and the moment of force. So before we go into that, what we will do is, you all know the setup here. We have the board, and to that another board is a plank is attached, and to that you can see a thin plank is attached to it. All these are wooden planks. And then you can see the different points A, B, C and D. And this one is the nut which we are going to use to tighten and increase the magnitude so that we can observe the magnitude of the force that is needed to rotate this plank. And from this will be the axis of rotation, that is the nut here or the screw here, and starting from there. So from the screw to point A, it's going to be 15 centimeters. Then to point B, it's 30 centimeters. C, 45 centimeters and D, 60 centimeters. So that's how the distance is going to be. First, we are going to understand how the moment of force works. So to do that, what I will do is, I will first attach this is the normal state of the screw. First, we will attach the Newton balance to point A. And as the plank starts to move, slightly move, you will have to get the reading of the Newton balance. So this is where we connect the Newton balance. So here I have marked the lines there so that you can see as the plank moves what the reading is. And we have to have the balance above the board. It shouldn't be touching the board. It has to be above the board. So you all know what to do now. Right, so if I try to pull it, so when I pull, you all can see, students, when it is 2 newtons, the plank just starts to move. So then what we do is we bring it back to the original position. Then I have to move the Newton balance to this nail. We can either use nails or, as shown in the book, we can tie a loop around the plank. We can mark the points A, B, C, D. And then we can place the loop at that point, connect the Newton balance to that and pull as well. So now the distance is 30 centimeters. Again, if I pull, you can see it's at 1 Newton force. The plank is moving. If we try again, when it comes to 1 Newton force, the plank is moving. Then the third one. That's point C, 45 centimeters away. So now here it's 0.6 newtons. I'll repeat again, 0.6 newtons. Then we move it to point D. So here it's 0.4 newtons. If I do it again, repeat again, it's 0.4 newtons. So can you all understand, students? When the point A was used, the force that we needed to apply was 2 newtons. And as we moved away from the axis of rotation, that is the screw, you know the perpendicular distance increases. This is the perpendicular distance. As the perpendicular distance increased, you were able to understand that the magnitude of force decreased. But when we get the multiplication, you will see the magnitude of moment of force will be the same value. Is that clear to you all? But in this activity, we are trying to understand how the moment of force or moment depends on the magnitude of the force applied. So to do that, what do we need to do? We need to tighten the screw. So it was the initial position here, and then you know we have to tighten the screw by half a turn. So I am going to do that. So now it has become tighter. Then we will use 1 point only. So to understand that, I will use 2 different points, the closest point A and the far away point D. So with point A, we will try. Now earlier you all can remember, students, it was 2 Newton force. Now when I try to pull, you can see when I apply a force of 3 newtons, it's starting to move, just about starting to move. So that's 3 newton. Earlier it was 2 newtons, now it is 3 newtons. The same way I will try for point D. You can remember students, earlier at point D it was 0.4 newton. So now we will try and see. Okay. So here we will look at the reading. It's moving when the balance is 0.9 newtons. So can you all understand the relationship, students? When we tighten the screw, again the amount of force or the magnitude of force that was needed increased at point A as well as point D. So then again I am going to tighten it by another half a turn. Okay, so again I am going to use point A and now we will try to move it and see. So here, so if I try to move it, you all can see when it comes to a reading of 4 newtons, the plank just started to move. So that is the third reading. Initially we had 2 newtons, then we had 3 newtons and now 4 newtons. The same way, if we use point D there, you can remember initially it was 0.4 newtons, then it was 0.9 newtons and now we will try to move it from the same point. Now can you all observe, students? When it comes to about 1.5 newton, you can see the plank just starts to move. So from these, I am sure you all can understand that when the distance increases, that was not our intention, but you all were able to understand when the perpendicular distance from this point of axis of rotation increases, the magnitude of force decreases. But we wanted to understand that the moment of force depends on the magnitude of the force applied. So at point A, you were able to understand when we tighten the screw by each half turn, the magnitude increased. The same way at point D also. So from this, we can conclude that when the moment of force increases, the magnitude of force that needs to be applied has to be increased when the perpendicular distance is a constant.